Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to PMDC online lecture room. Today we are going to discuss the 8th topic of liquid chapter, that is viscosity. Dear students, this topic is present in chapter number 5 of first year chemistry book. The important short questions about board exam of this topic are: briefly discuss the effect of molecular shape on viscosity. This question was appeared in 2015 at Viscosity. Question number 2. What is viscosity? Write factors affecting viscosity. Dear students, this question was appeared in 2017 at Viscosity. Question number 3, that is define viscosity. How can it be measured? Dear students, this question was appeared in 2017 at cohort board. Dear students, today our lecture consists of introduction of viscosity, explanation, factors affecting and measurement of viscosity, and the last part of our lecture is assignment. So first of all, introduction or definition of viscosity. Dear students, the internal resistance to the flow of liquid is called viscosity. Viscosity is represented by a Greek letter eta. Dear students, eta is represented by this symbol. Now, units of viscosity. Dear students, the SI units of viscosity are Newton second per meter square or kilogram per meter per second, while other units of viscosity are gram per centimeter per second. This unit is also known as poise, which is represented by P, where 1 poise is equal to 1 gram per centimeter per second, or 1 poise is equal to 0.1 kilogram per meter per second. Now, explanation of viscosity. Dear students, as we know that viscosity is due to internal resistance of liquid layers. Liquids which flow very slow have high viscosity, such as honey, glycerine, etc., while liquids which flow fast have low viscosity, for example ether, water, etc. Now let's consider the flow of a liquid in a tube. Let the liquid is composed of several layers. Look here, dear students, these are the several layers of liquid within a tube which have different velocities. So the different velocities of these layers is due to dragging or opposing force. Dear students, each layer exerts a drag on the next layer and causes resistance to flow. The layer which is in contact with the walls of the tube remains stationary. For example, this layer and this layer is in contact with the wall of container or tube. That's why these layers look like stationary due to very low velocity or strong adhesive forces, while at the center will have less resistance and thus will have maximum velocity. For example, this is the central layer which has maximum velocity due to low dragging force. Dear students, as we go away from the wall of the tube, the velocity of liquid layers increases due to decrease in the dragging force. Now, coefficient of viscosity. Dear students, the force required to maintain difference of velocity of 1 meter per second between two parallel layers of a liquid which are 1 meter apart is called coefficient of viscosity. Dear students, the unit of coefficient of viscosity is poise, where 1 poise is equal to 0.1 kilogram per meter per second. Now, factors affecting viscosity. Dear students, there are several factors which affect the viscosity. Number 1 is intermolecular attractive forces. Dear students, stronger the intermolecular attractive forces between the molecules, higher will be the viscosity. For example, sulfuric acid and glycerine are more viscous than ether because there are strong hydrogen bonding among the sulfuric acid or glycerine, while there are weak London dispersion forces among the ether molecules. Similarly, water is more viscous than methyl alcohol due to strong intermolecular attractive forces, that is hydrogen bonding. Second factor is temperature. Viscosity of liquids is inversely proportional to the temperature. Increase in temperature results into the decrease of intermolecular attractive forces. For example, the viscosity of alcohol at 0 degree centigrade is 17.7 millipoise. If we increase the temperature of alcohol from 0 degree centigrade to 50 degree centigrade, so its viscosity is reduced to 7 millipoise. Third factor is molecular size. Dear students, the viscosity of a liquid increases with increasing molecular size. Thus, bigger molecules with higher molecular weights are difficult to move than smaller. For example, grease, fuels, oil, glycerine, and other long chain molecules are more viscous and thus offer more resistance to flow due to large size. Fourth factor is molecular shape. Dear students, irregular shaped molecules offer more resistance to flow as compared to regular shape because regular shaped molecules have smooth surface and thus can easily slip over each other. For example, molten sulfur at 140 degree centigrade is less viscous than the sulfur at 190 degree centigrade because at 140 degree centigrade the molecules of sulfur are ring shaped, while at 190 degree centigrade the liquid sulfur is made of long chain of number of sulfur molecules. Now, measurement of viscosity. Dear students, it is not easy to measure the absolute value of viscosity of a liquid, but relative viscosity of a liquid can be determined easily. The relative viscosity is defined as the ratio of the viscosity of liquid to the viscosity of water taken as standard. The viscosity of water is taken as 1 centipoise at 25 degree centigrade. Dear students, the viscosity of a liquid can be measured with the help of a Stewart viscometer. Dear students, this is the Stewart viscometer because this viscometer was constructed by Stewart, which is consist of two bulbs, that is bulb R and the second bulb is bulb S, which are connected to each other through a capillary tube. Dear students, this is the capillary tube. There are two H marks on the viscometer, that is mark A and B. Clamp the viscometer on a stand in a vertical position, then introduce definite volume of distilled water in the bulb S, then suck the water in bulb R till it rises above the mark A. Now the time of flow for water between mark A and B is noted. Now the same experiment is applied for the test liquid, and this way the viscosity of the test liquid is determined by the following equation. The viscosity of the liquid is equal to viscosity of water multiplied by density of liquid multiplied by time of the flow of liquid divided by density of water multiplied by time of the flow of water. For example, find the viscosity of ether at 25 degree centigrade. Given data is given, for example, viscosity of water is 1 centipoise at 25 degrees centigrade, time of the flow of water is 60 seconds, time of the flow of ether is 20 seconds, density of water at 25 degrees centigrade is 0.997 gram per ml, while density of ether at 25 degrees centigrade is 0.7 gram per ml. Dear student, the required data is viscosity of ether. This formula is used for the measurement or calculation of viscosity of ether. By putting the data in the above formula, we can get the viscosity of ether by cancelling the units. So we can get the viscosity of ether, that is 0.234 centipoise at 25 degrees centigrade. Now last part of our lecture is assignment, which consists of 2 questions. So dear students, carefully watch the video lecture and do the assignment. Thank you very much and take care.